In this video, we're going to look at finding the surface area of regular pyramids that have a triangular base. So you can see this forms a triangle, and all three sides are 9 centimeters for the base. And notice I did shade in the base to make it more evident where it's located. Now, first we're going to find the lateral surface area. So to find the lateral surface area, similar to the one that we did that was even square, we're just going to go ahead and do 1/2 times the perimeter times the slant height. In this particular problem, the slant height is given, so notice that it's given it to us, and it's 11.3 centimeters. So now what we're going to do is we're going to go ahead and substitute these numbers in and solve it. So my LSA is going to be equal to 1/2, and then for P, we're going to put in our perimeter values. So we have 3 sides to this particular base, right? 3 sides to it, and I'm going to go ahead and just draw a triangle over here real quick. So imagine I'm going to draw it right side up. If this is my base, right, it's 9, 9, and 9, and we're going to use that image again in just a minute. So that's our base. So I'm going to go ahead and add those values. We have 3 9s, so it would be 9 plus 9 plus 9. And then our slant height is 11.3 centimeters. So 11.3. And we're going to put this in the calculator and see what we get. So now I'm going to go ahead and I'm going to put this in. So let me go ahead and do alpha y equals enter. I'm going to put in 1/2. And after the 1/2, we have our perimeter. So parenthesis 9 plus 9 plus 9, because we have 3 sides in our shape for our base. And then the slant height, 11.3. And notice we get 152.55. So our LSA, our lateral surface area, is equal to 152.55 centimeters squared. Now let's go ahead and let's move on, and we're going to do the total surface area next. Now for the total surface area, we have already calculated our lateral surface area, which is represented by this part of the formula. So for that part, I'm not going to enter it back in. I'm just going to put in 152.55 for the lateral surface area. And then we have to add the area of the base. Now notice that once again, with a pyramid, we only have one base, but we do have to find the area of it. And unlike the square-based pyramid, we actually have a triangular-based pyramid right here. And so we do need to find the height of this triangle in order to use the area formula of a triangle. And by the way, when we're finding an area of a triangle, it's going to be equal to 1/2 the base times the height. So 1/2 the base times the height. Now, in order to find the height, we're going to have to take this base right here and cut it in half to form a right triangle. The reason it's important to do this is because once we form a right triangle, we can go ahead and calculate the length of this line right here, which represents the height. So I'm going to draw a line from it that'll represent your height. And then the base is just this number down here at the bottom. So B is going to be equal to 9, but we do got to do some work to find the height. Now we're going to use the Pythagorean theorem in order to find the height of this triangle right quick. And then we'll go ahead and we'll start substituting our values so that we can find the area of the base. So let's go ahead and use that Pythagorean theorem. I'm going to write it down here at the bottom. Remember, it's just simply a squared plus b squared is equal to c squared. And the values that I know is I know that this whole side of the triangle is 9. So if I cut it in half, that'll be just this portion of the right triangle. In other words, this leg. So that one leg is going to be 4.5, which is half of 9. So I'm going to substitute my values. So this 4.5 is going to be representative of B in the formula. We're looking for H, and that's really, H is our A, right? This would be the A leg of the triangle. And we know our hypotenuse, it's 9, right? Because directly across from the right angle is the hypotenuse, and this side of the triangle, that whole side, is 9. So I'm going to substitute those values. So we don't know what a is. We're looking for it. So I'm going to leave it as a squared. We know what b is. We know that it's 4.5. So I'm going to put in 4.5 in parentheses and square it. And then c squared, we know that it is 9, because that's one full side of the triangle, the hypotenuse. So now what I'm going to do is I'm going to go ahead and subtract this 4.5 squared from both sides. So minus 4.5 squared. Alright, so I'm going to take 9 squared, and I'm going to go ahead and subtract 4.5 squared. And it leaves me with 60.75. Now, over here on the left, I'm going to bring down my a squared and my equal sign. And remember, we don't want the area behind that side of the triangle. We actually want to go ahead and get the linear measurement. So I am going to take the square root of it to cancel out the square on my a. And therefore I end up with a is going to be equal to, and I'll do second square root, put my answer in there, hit enter, and notice it's 7.794. 7.794. And now I'm going to go ahead and round this real quick. So if I round it, it just becomes h. I'm going to change that a to an h, right? Because this really represents the height of our triangle, 7.8 centimeters. And now we're going to use this value in our formula for our height in order to find the area of our base. So let's go ahead and go over here. We already know that this right here represented the 1/2 times the perimeter times the slant height represented the lateral surface area, and our value for that, I'm going to put that in parentheses, is 152.55, and we're simply going to add that to big B, which is our area of the base. And to find the area of the triangle, we're going to go ahead and do 1/2 the base of the triangle, which happens to be 9. So times 9 times the height of the triangle, which we found was 7.8. And now we'll put this all in the calculator and we'll have our final answer. And I realize for you watching the video, it may look confusing with these dots everywhere, so I'm going to actually put this in parentheses in here to show it's being multiplied so that there's no confusion about the decimal. So parentheses 152.55. That represents our lateral surface area, our 1/2 times the perimeter times the slant height, and then plus the area of our base of our triangular base. So I'm going to go ahead and do alpha y equals enter to get my fraction bar, 1/2 parenthesis 9 close parenthesis 7.8, which is the height of our triangle. So that's the base of the triangle times the height of the triangle, and then close parenthesis again, hit enter, and it gives me 187.65. And that is our total surface area, or what I like to call TSA. So now we have solved for the lateral surface area, and we have solved for the total surface area.